Section 7.1. This is inverse functions. All right. The one stipulation for inverse functions is they must be one-to-one. In other words, every x can only have one y, and every y can only have one x. You can do this a variety of ways. But the easiest way is to graph the function and look at it. And the graph of this, a very rough sketch of the graph, goes like this. Oops, that should have been symmetric. All right, and so the point is, do the vertical line test on it, do the horizontal line test on it, and you'll notice when you do the horizontal line test on this, it crosses in 4 spots. So this function is not one-to-one, so we cannot find an inverse for it. Now, we could always narrow down the domain to make it work and only use like maybe the first piece from here to here and stop it at, this spot is -1, I believe. And so you could restrict the domain, but that's not what they're talking about here. This one says determine the largest possible intervals in which this function is one-to-one. So we could go from -infinity to -1, or we could do -1 to 0, or we could go 0 to 1, or 1 to infinity. Any one of those intervals, the horizontal line and the vertical line test will work. So that's what they wanted you to do on example 1. Example 2. Does an inverse exist? Determine the intervals on which f of x equals x squared minus 1 has an inverse function. Well, if you look at that, that's just the graph of a parabola that is shifted down 1. So I can look at this and I can see it's not one-to-one. So I would have to restrict my domain on this, and I could use from -infinity until I get to 0, or I could use from 0 to infinity. So that's the first thing you better do, is determine if it's one-to-one. Example 3 actually has us find one. Find the inverse or inverses of the following functions. Restrict the domain if necessary. F of x equals 2x plus 6 is part A. That's a line. It's not horizontal or vertical. It's a diagonal line, so it is one-to-one. So I know that much. So the first thing I do is I make this a y, and then in order to find inverse functions, if you remember from your pre-calc or even college algebra, you switch the x and the y, and then you solve it for y. And you could have written this several ways, but the actual inverse function, you're not finished until you write f inverse of x is equal to x minus 6 over 2. It also could be written as 1/2 x minus 3 if you wanted to simplify it. Sorry for all the beeping. They have a lot of announcements this morning. Okay, f of x equals x squared minus 1. Now that's the parabola we were just talking about in example 2. And we said we had to restrict the domain on this one. So we're going to take, they want us to take both of them? Yes. We're going to restrict it for 2 different domains. It's one-to-one if we go from -infinity to 0 and from 0 to infinity. So we're going to restrict it to one piece. So the first thing we do, we make this a y. We switch the x and the y. We solve for y. Now, when you take the square root of both sides of this, you actually get 2 answers. So my answers to this would be f inverse of x is equal to the square root of x plus 1 if I use the right side of the function, or f inverse will be negative the square root of x plus 1 if we use the left side of the interval. So this is when we're going to use right side, 0 to infinity, and this one's when you're using -infinity to 0. Example 4 is using example 3. They want us to graph the inverse functions, plot f and f inverse on the same axes. So part A is the y equals 2x plus 6. The easiest way to do this is to plot 1, then get those dots and reverse the x and the y. Don't work real hard at plotting the inverse. So this one starts at 6 and has a slope of 2. Oops. That should be further over. And so this line, and it helps if I have a ruler, goes here. Now take those dots. This bottom dot here is the dot 0, 6, so its inverse would be 6, 0. Just switch the x and the y. The next dot was 1, 8, so we're going to graph 8, 1. The next dot was 2, 10, so we're going to graph 10, 2. And I think my x-axis is a little bigger than my y-axis, so it's not going to look quite right. Now, if you graph the y equals x line, you'll see the mirror. The y equals x line is 0, 0 is the y-intercept, slope of 1. And unfortunately, probably all of this came through in one graph. Now, what's supposed to happen down here at the bottom is that these two lines should have touched on the mirror. If I was using actual graph paper, it would have been easier. But that's how you know the mirror effect is having. Your dotted line, the y equals x line, is your mirror, and it's reflected. So all you have to do is graph the original, switch the x and the y, and graph the inverse. Now, the second part, they want us to graph the positive half. They want us to do f of x equals the square root of x minus 1. Oh, this is actually a different question, isn't it? Yeah, but it'll still work. Okay, so square root of x minus 1 is that sideways parabola, half of a sideways parabola. Again, we're going to graph the y equals x line. Put a dotted line there. Plug in dots. If I can't put in 0, I can put in 1. 1 will give me 0. 2 will give me 1. And 3. 3 will give me 2. I don't want to go 3. I want to go to 5. 4, 5. 5 will give me the square root of 4, which is 2. So this graph goes like this. The inverse, then, I'm going to graph, instead of 1, 0, I'm going to graph 0, 1. Instead of 2, 1, I'm going to graph 1, 2. And instead of 1, 2, 3, 4, 5, 2, I'm going to graph 2, 5. And so this one goes like this. It's the right half of the parabola. And you've got your mirror.